in this case, I also want to thank Dr. Vũ Thị Thanh Bình for hosting and for coordinating this seminar. And I would like to thank all the participants for taking the time to join us today. Your engagement and your encouragement is what make our academic exchange meaningful and impactful. I think it's not about we have the MOU, we have the actual action in collaboration, in research, in teaching. And I do hope that sessions today will not only deepen our understanding of quantitative methods, but also inspire new research direction for future collaboration between our institution. As I mentioned before, so after this session, we will form some teams to collaborate in some new manuscript, in some new topic, and in some new project also. And thank you very much again, Dr. Kazi, Dr. Naila, and wishing all the participants today have a great success. Thank you very much.
Thank you, Dr. Thuy, for your speech. So from the speech of Dr. Thuy, so you can know that from the workshop, we will have more collaboration in the future, and we also hope we have some team, and you can if you have the interest in the Kazi research interest, please contact to Kazi or me to match a team. So for now, I will have a short brief about the speaker today, and you also know more about her research interest. The workshop today is focused on the method of moments quantile regression for panel data. So you know that in accounting and auditing sector, we all often use panel data from the financial statement. So you can apply this method for the future research. With Dr. Kazi Musa, I would like to introduce a little bit or the short brief about him. The current position of Dr. Kazi Musa is a postdoctoral fellow at the Accounting Research Institute at the University of Technology in Malaysia. Kazi research interests focus on development economics, good governance, budget deficit, public debt, welfare economics, energy economics, green economy, financial economics.
Excuse me, doctor.
Political economy.
I think so you shared the wrong screen.
Thanh Bình, so you need to share again the screen. So you share.
Oh, so I'm sorry. So I will say again.
I just see my photo in the screen and sorry.
I'm so sorry. Yes. So you can see the research interest of Dr. Kazi Musa in the screen. So if you focus or you have the same research interest, you can connect with Dr. Kazi Musa. Please contact me to have more information. And about his education, he is also PhD from the UiTM Malaysia in 2022. And today, for now, he also pursue his master in economics of sustainability at Torrens University of in Australia. From the publication, you can see Dia's top 10 of Kazi publication, also published in the high journal ranking. So you can read, and if you see the same interest, please contact with Dr. Kazi Musa. Yeah. Thank you, Dr. Kazi Musa, to join today. And for now, I hope you can share some guide for the audience about use MMQR in analyzing panel data.
Thank you very much. Thank you very much, Prof. Tai Hong and Dr. Vin. Thank you very much for inviting me. May I share my screen, please? And good morning, everyone, for joining. We will try to learn together some of the econometric tools. Maybe many of you already know many things more than me. I'm just learning, trying to learn something new, and which I can, some of it I can share today. And during presentation, if I go fast or you have any asking, immediately you can stop me and ask question, no problem. I'll be more happy if you just stop me and ask anything, like to go slow, or if you need to listen things twice or more in clarification, just ask, no problem. Okay, dear colleagues, today we are going to learn about advanced econometrics. One of the new method is quantile var moment. We will learn and practice today. And this is Kazi Musa from Accounting Research Institute, Malaysia.
Excuse me, Kazi. So sorry for interrupt. For everyone, so I will send the link of datasets via the chat box. So you can access the data for practice.
Okay. If you find anything important in text, please inform me. Yeah. So today's contents are like panel data structure, the essence of quantile regression, because quantile have it has many variants. Some of them we will learn today. One of them is like standard quantile regression, and another one is simultaneous quantile regression under bootstrapping. Then panel quantile var moment with scale and location effects. Then some graphical representation. And if we have time, we will try to learn a little bit about dynamic ordinary least square regression, as well as fully modified least square regression and interpretation of these methods. So very first, we already know, I know all of them know, still we are just reminding again, just have a little bit review about the panel data. Panel data or longitudinal data combine cross-sectional data, like multiple entities. It can be country, company, or individuals with time series data, multiple time periods of the same company or individuals or company, observing the same individuals, firms, or countries repeatedly over time. So it means like several entities and several times. This is actually panel data. We are going to focus panel data today. Maybe some other days we can focus on time series and other data. So to come to the quantile regression, first, it comes from the shortcomings of ordinary least square. We know that ordinary least square, or OLS, is one of the basic and standard, and one of the very popular method and also one of the strong, we have to say. But it has some shortcomings. So to overcome that shortcomings, quantile regressions come to offer some more insight and some robustness. Like in Welles method, outliers hurt really badly. Like if there are some outliers in panel data, Welles is less robust to deal with that outliers. And even like if data points are deviated from normality, so that abnormality or outliers, it might have, it not might have, it will have like quadratic effect on the error terms. That's mean it gonna make some issues in to produce reliable estimation result. It characterized like in for Welles, it character is like average or mean value. It produce coefficients or analysis based on the mean value. So mean value, whatever we have, like different data point. Later on, I will show in board. Like usually we have data point in different places, but in Welles, it assume an hypothetical curve which is like in 45 degrees. That's mean it assume like an average or mean value to analyze. Means are somewhat problematic in many cases. Like it makes mean whatever we have, it create a mean, then it analyzes. So from method, it has some weakness if data is like not normal. Usually data not normal. We make it normal with several ways, but non-parametric test or semi-parametric test like quantile regression, it has some other strategies to deal with all these things. So Well is also very sensitive and assume linear relationship. It always thinks the relationship between dependent and independent are really linear, but often the relationship is not linear. We have to think about that. And potential for inconsistency with endogeneity. If there are some endogeneity in the framework, if dependent variables are correlated with the error terms, then this is like endogeneity. It cannot deal with this sort of things or any other abnormality. Usually, Willis avoid those things. So why we want to use quantile methods? Squid variable. If data has like skewness or kurtosis, like unequal effects in different quantiles. Quantiles mean like full data, we can assume from 1% to 100%. So it can, quantile regression, it can create the lowest group, like from 1% to 10%, 10% to 20%, like this, to 80% to 90%, like this. It can create different groups to avoid those abnormality in different point, like extreme points of data. Cross-point data like quantile, quite hard to interpret OLS result if the data is top or bottom limited. If data like very close to the hypothetical curve, like 45 degrees, and if it is like very deviated from very far, OLS cannot interpret that data. Therefore, we have to use Quantile to address that issues. Outlier do not hurt estimation as bad. Heteroscedasticity and unequal variance. If there is heteroscedasticity, also OLS cannot do, which can address by quantile regression. Modeling extreme values, we already say that how extreme values can be addressed by quantile. I will show in both later on. And understanding different segments, like if data even is normal, but our goal to provide information of different segments of the data point, then we can use quantile again. Even the data is normal, we also can use this. We care about specific effects or different quantiles. I will show you how quantiles can provide different specific effects of different groups of the data. The dependent variable is continuous without too many repeated or missing values. This sort of things, for this sort of things, we can use quantile regression. Main idea, like estimate regression for several segments. It will create several segments in the method for dependent variables to achieve better fit on each of them. Regular OL is approximately only over one segment. Like whatever we put in OLS, it's gonna produce like one coefficient. Like to make everything one average, then can produce the result. But in quantile regression, you have the freedom. You can make many segments, maybe 10, maybe 5, maybe 2, like this. So now we can go to practical session. So this workshop will be mainly applied practical practical part. So we can start with practical. Prof already yesterday shared some data. We can use that data. Let me open.
Yeah, Dr. Kazi, can you send the draft for the code? So
Oh,
everyone can practice use the code without writing the code. They can use your code.
oh yeah, sure,
Yeah.
sure. Let me do that. Or I can send the slides.
Yeah.
In slide, you can find all the codes.
Yes, thank you.
I can WhatsApp you or in the chat box.
Thank you, Kazi.
Okay, I can just share here. You can share with them.
Yes, thank you.
So, okay. First, I'm going to. So I hope you already installed Stata. If you don't install, then a little bit critical for now. Like if I want to transfer, it gonna take time, and install also need time because this is like cracked version. The original version is really expensive, therefore I have to use the cracked version. And to install, you need to watch a video, then you can install this. If you need later on, you can contact with me. This is Stata 17 version. Now maybe 18 or 19 is available, whatever. I'm still using 17. In the meantime, if any of you have any question, you can ask me. Is there any question in chat box? If no, we can just go. So what you can do very first,
Yeah. So this I will see some the code. You write on the screen, and is this for the data sets I will send to the audience?
yeah, you can share same data the yesterday you shared with me. Same one. Same one, but we will consider only few variables to demonstrate to avoid any other issues. Therefore, we'll take only few variables. And same way, anyone can try to use that. So what you can do, you can just copy all the data, your targeted data, and you have to go to data editor and just paste it here with variable names. So I wanted to consider like leverage also, but leverage has some issues. I didn't find what is maybe some text or something. Therefore, we will not gonna consider leverage today, but some other variables.
Yes. So excuse me, so I need a little bit time to explain in Vietnamese about the data set, right?
Yeah, sure.
Kính thưa các thầy cô và các bạn, thì trong cái phần mà link mà gửi cho các thầy cô trong chatbot ấy, thì là nó có một cái bộ dataset để các thầy cô có thể nhìn thấy có rất nhiều những bộ dữ liệu từ mà em đã chuẩn bị từ năm 2008 đến 2020. Đây là bộ dữ liệu mà nhóm nghiên cứu trước cũng đã làm rồi. Thế thì hôm nay thì cũng sẽ thực hành. Tuy nhiên trong cái phần dữ liệu thực hành này thì Dr. Kazi sẽ có sử dụng một số cái biến ở trong này thôi. Thế còn sau đấy rồi thì cái phần mà làm thì nó sẽ có thể mọi người có thể là tùy trên cái nhu cầu của mọi người. Ở đây thì mình sẽ sử dụng mấy cái biến ban đầu mà diễn giả có dùng mấy cái phần đôi vàng và cái biến phụ thuộc ấy ạ. Thì ở đây nó sẽ là các yếu tố liên quan đến quản trị công ty, ảnh hưởng đến hiệu quả hoạt động, cái firm performance ạ, và sử dụng ở đây là financial performance. Và ở đây thì chỉ sử dụng có một phần cái đầu tiên là ROA là để mình thực hành thôi. Còn sau này mọi người có thể thử với nhiều những cái góc cạnh hơn. Ở trong cái bộ dữ liệu này thì nó cũng rất là dài và nó có các đặc điểm liên quan đến Board Director là cái ký hiệu là chữ B, và cái phần thứ hai là liên quan đến ủy ban kiểm soát là Supervisor là S. Ở đây mọi người có thể có thấy hoặc là một số cái cơ chế liên quan đến gọi là Control Mechanism là biến liên quan đến kiểm soát ở trong cái gọi là Corporate Governance ấy, thì nó sẽ chia ra các thành phần. Thứ nhất đấy là Board of Director, thứ hai là Supervisory, và phần thứ ba đấy là Control Mechanism. Thì ở đây nó sẽ có một số cái biến ví dụ như là both side, both independent, vân vân. Thì cái việc đo lường biến thì nhóm nghiên cứu sẽ hơi không công bố hết về cái việc đo lường, tuy nhiên thì nó cũng sẽ có những cái phần mà đo lường ở biến nó sẽ giải thích. Cái phần thứ hai đấy là liên quan đến ban kiểm soát. Đây là những cái quy định về việc là thiết kế một cái cơ chế quản lý theo cái quy định về pháp luật về việc quản lý ban quản về corporate governance trong các doanh nghiệp, nghĩa là có luật liên quan đến ban điều hành này, hay là ban kiểm soát, và một số cái phần liên quan đến việc là kiểm toán là nó sẽ nằm ở trong cái phần đấy là cơ chế kiểm soát. Thì các thầy cô có thể sử dụng những cái biến này để các thầy cô có thể thực hành. Trong phần bài thực hành ngày hôm nay thì diễn giả sẽ sử dụng một số cái biến, khoảng 3 biến thôi ạ. Còn về các thầy cô có thể thực hành nhiều hơn, bộ dữ liệu gửi cho các thầy cô thì cũng ngắn hơn, rút gọn hơn ạ. Okay, you can continue. Thank you so much.
Yeah, Doctor, one thing like.
So I explain about the data set for the audience lecture about the characteristic of data sets. So for now, we will practice in the data.
Yeah, Dr. Binh, like this is both sides, right? This one is both sides. This one is board
both independencies.
Independency, and this is board
Yes.
meeting maybe,
Board
right?
meeting, the number of meeting in the year,
Yeah,
and
yeah.
both female.
Female,
So
female.
15,000 percentage of males, female
Mhm.
in board of director.
Yeah, yeah. Okay, thank you. I want to share one thing. Stop sharing. I guess you can see the board. Can you?
Yeah, you can see.
Yeah, yeah. So let me draw first line. So, okay, let me draw here. One.
Kazi, can you change the position of the computer? It's not so clear to see the board.
So please, so I think we will wait after he finished the writing on the board.
Yeah, okay.
Yeah, after
Yeah.
that, I mean. So, Wales regression, if you can see, is it visible? This is like Wales regression. Our data point is here and there, but Wales regression think data is like an hypothetical curve of like 45 degrees. It assumes it's like mean value. Mean. It assumes like that. The dependent variable is like this. But in quantile regression, data may be similar. So what it can does, like it makes several segments. Like here, like one spike, it can take one. This another spike here, downside. So it can make another here, another here, another here, another here. So it will analyze like this one separately, this one separately. If you can see like every segment, this is like 10%, 20%, 30%, like 80 or 90%. So to track every segments of the spikes, like this, like one type of values are here. So it's gonna make one segment and analyze this part, and this like another segment. It's gonna be analyzed with another part, another regression. Therefore, earlier it gonna provide only one coefficients, one result out of all these. Therefore, these values, these extreme values, usually ignored in ordinary least square or OLS. But here in Quantile, like here some extreme value, here very low extreme value. So both are counted. This is one of the strength of quantile regression, if you can say. So we're gonna show it practically how it works. So we already load the data. I have to, how can I remove this? One second. Okay. You can see my state interface, right? I hope so. So these are our variables. Fortunately, Dr. Binh already make ID, so we don't need to create another ID. But if there is no ID in panel data, we have to make it manually, like by make some comment here. You can make it. Very first, we have to see the we have to make comment for panel data. Since we already have ID, we can make like xt set. If it was like time series data, we could have used ts set. For panel data, we have to make comment xt set, then id here, then enter to see the this like panel data. Stata now know this is panel data, and we can see data is like unbalanced. So if we just, there are many variables, can I just, since we are focusing only few variables, I want to drop some of the variables to avoid like
Here, the Kazi, so for this characteristic of the dataset, you can show that for some variables such as beside or be int or be mid is balanced. However, some other variables such as so I think, for example, state ownership or foreign ownership is include some missing data, so it trigger unbalanced data for total data set. However, for or 5 variable you use in this model is balanced data.
yeah.
Yeah.
Okay, you can translate whatever I'm saying. So we can drop, we will consider this framework, right? Like ROA, then board size, then board meeting, and female board member. These few variables for practice we can consider. Rest we can drop to make it like easy to see. So board size we have to consider. Board, this one no need. Board meeting, this one also no need, no need, no need. Yeah, so we will have board size. Okay, so if you want to drop any of your variable, you can just make a command drop. Now it's like more easy to see, easy to deal with. So if we want to see like summary of our variables, like how many observations, mean, standard deviation, minimum and maximum values. Leverage has some issues, therefore it's not showing here. Whatever, we have to continue with that. So we need to transform our data. Very first, I want to show another thing. Yeah, first we can so data has some issues, therefore we need to transform to data into logarithmic form to harness the estimation. Any data, it's better to transform in logarithmic form. How we can do that? Generate, therefore we can make a command gen. Then for board size, we can just write logarithmic form L. Then log board size. So this way we can generate log form of the data. I am doing this for all our data. Board meeting.
Dear Dr. Kazi, so some case we use log, and in some case we no need to use log, right?
Yeah.
For example, we use ROA, it's small, so I think you can't use
I want to show you one thing.
natural, yeah.
Like the value of board size is 5. Board meeting is 32.
Yeah.
32 times in a year. But female board member, even less than 1. And ROA is less than 1, only 0.26, 0.1. And board size, oh, this is like, yeah. So here 5 and here is 32. 32 is a big value compared to only 0.11.
Yes.
So to standardize the data for any regression,
yeah,
it is recommended to
Please for me explain in Vietnamese because I have some PD or master student join yesterday. Yeah. Xin các thầy cô và các bạn, trong cái trường hợp mà chúng ta sẽ có, nếu mà các biến của mình ấy mà không phải mấy đến 1, nghĩa là nó trong một cái ngưỡng rất là nhỏ, thì thường cái biến động của nó không lớn, cái variance của nó sẽ rất là nhỏ, thì mình cũng có thể là sử dụng luôn cái biến đấy mà không cần phải log. Tuy nhiên ở một số cái trường hợp cái biến của nó dao động rất là lớn, ví dụ bình thường với đòn bẩy hoặc là ROA ấy, nó sẽ là cái biến vào trong khoảng 1 thì dao động ít. Nhưng mà tự dưng có một cái biến mà mình sử dụng, chẳng hạn bên meeting này, chẳng hạn có những cuộc họp trong một năm, có những công ty mà họ họp rất nhiều, họ có gọi là gặp vấn đề đấy ạ, họ họp rất nhiều, thì nếu mà mình sử dụng như thế thì nó sẽ dẫn đến là cái độ lệch nó sẽ rất là lớn. Nó cái này mình sẽ sử dụng để kiểm soát cái outlier của mình, nên mình sẽ sử dụng log. Đấy. Thì là lý do tại sao mà trong một số biến thì diễn giả đang sẽ sử dụng log, ví dụ như là bên miss, beside, thì là những cái biến mà mình sẽ sử dụng để làm sao mà khi mà cái hệ số beta mình chuẩn hóa giữa các biến ấy, nó sẽ gần như nó sẽ nhỏ lại. Ví dụ nếu mà không dùng cái biến thực ấy thì nó sẽ dẫn đến là cái độ một cái thì 0,00 mấy, một cái thì 0, mấy, hoặc là nó lệch nhau rất là lớn. Đấy là lý do mà người ta sẽ log ở trong một cái số biến mà giá trị nó lớn ở trong cái biến thực ạ. Okay, thank you so much. So you can continue.
So we okay, let me transform other variables. So generate, same way you can generate like the L here, like we are creating a new variable out of our old variable. Female board member. BFA. So generating, there are many missing values, whatever. So we already transform our data to natural log. So by this command, you also can do that. It's like generating new variable actually. So if you want to put all this, because we're gonna use these variables many times, quite frequently, therefore we can order if you want to put this variable first, so now you can see like these variables come very first. So we can order our variables here. The variables we're gonna use frequently, we can make order by this command. So now we can see the descriptive statistics. For descriptive statistics, there are several ways to make it. One is like sum, any variable like ROE, details. So this like individually for one variable, we can see observation, mean value, then skewness we also can see, corpus also we can find here from this command, and see the percentile of the variable. Like lowest percentile is -4 and highest percentile is this a big value. These are the most highest values. So individually for every variable we can see like this. And combinedly also we can see for our research paper we usually use this command. Any of you are practicing with me, you can just take this command from the slides and put it here. So it was like for another paper, you can just remove the variables. Previous for another paper it was. We can put variables for our paper. Our paper's variable we can take maybe ROE, then board size, board meeting, and female board member. So maybe we can just focus this. So this interface is showing many times what I can do with this. Whatever. So can you see like this is the command. If we execute this command, we can find for every variables many details of like number of observations. You can see number of observations are different because there are many missing values. Like ROE has the highest number of observation, then board size and board meeting are same, but female board member has many missing values. Whatever, the quantile regression still can deal with it. Then you can find the mean in different percentile, standard deviation, then skewness and corpus we can find here. And we can see in corpus little bit abnormality here in board size. Board member though, like it seems normal here. We will go for further check. Are the data really normal or not? Like for Jacob-Barra test, JB test, like yeah, immediately we can do. For normality test for every variable. Okay, for ROE.
Excuse me, Dr. Kazi. So, is there any difference between the normal or non-normal distribution in dataset in this step? The results can be normal or maybe no normal. No normal. So, is there any difference to do in the further step?
What, doctor? I didn't get it well.
I will ask for this step. You can describe the variable. So in this case, a variable is normal data, right? If any different in this case, the results show the non-normal.
Like if data is not normal,
Yes.
and still we consider like ordinary least square OLS we use. OLS cannot deal with abnormal data. That means still it can produce some estimation, it can produce, but the estimation is not actually reliable.
Yeah.
Therefore, we need to.
So, what is the solution? We can eliminate some outlier.
Yeah. Also we can deal like to drop some variable or
Observation.
or the method by itself can drop the extreme values.
Yes.
So if the method drops some extreme values, we cannot give actually the actual picture because we already dropped some values. Yeah.
It's very important because some my student when they do the thesis, they collect the data and then they do analysis. However, when I read the results from the descriptive statistic, I saw, oh no, you can't rely on the results.
Yeah.
So I would like to show everyone that when we do analysis, please focus on the data quality. Please do the further analysis. Please check the data quality, especially the normal data characteristic of your data. Yeah, thank you so much.
Doctor, do you know how to like remove this one? Because it comes frequently like this one. I don't know how to deal with this. Oh, I can just put it here, maybe. Yeah, upside. So we can go like here, we find data is almost normal. But if we go for the same command without log form, like our actual data. Actual data, like it shows like very weird descriptive statistics. And you see the skewness and kurtosis highest value it shows. Like original data is highly abnormal. Actually, most of the data is like abnormal. So to deal with abnormality, there are many things can be done. Like one thing is like transformation to log form. If we just transform the data or variable to the log form, so data already standardized. Like here we can see like these are the log form. Now data is like almost all the values are similar, standardized. So now they can fight each other because they are like almost similar. Earlier, it was like Trump, highly powerful, like 32 value. And this one, ROE, was like Venezuela, only 0.26. So they cannot like standardize, they cannot fight because 32 is a full value, it's very powerful, very big. Compared to that, ROE is like very small. So to deal with that, we transform the data for dear students. If you still have confusion why we change the data to logarithmic form, you also can do that. But actually, there are many methods in research, in analysis. Different method have different style. For I also find another for like who collect survey data. For that, sample is really great. But for a little bit big data, we can go for regression analysis or causal inference also can be used. Prof said asked me to conduct causal inference with DID. Maybe in future we can do that. However, this is like descriptive states. Now we can see still Jacobera JB test for like female board member. It also shows like data is like the value, p-value should be like close to 0.05, but it's like very different. That's mean data is still after even transformation, data is not normal. And we can go for some plot. For the plot, we can see, yeah, like, okay, we can test several plots. Yeah, here also you can see this is the normal line of the data, the bluish part. And out of these are the like extreme values here. These dots are the extreme values. Here also extreme values. Like when we give this command, we find data is like almost normal. But when we go with different tests graphically with individual variable, then we can find still data is like abnormal. You saw this figure right here. Okay, we can do it again. Okay, we can do for another variable maybe. This variable, it shows like normal, like there is not much extreme value here. Mainly this data, this variable is normal, female board member, but ROE is like abnormal. We can check board size. Yeah, it's like it has many extreme values. That's mean after event transformation, still there are some issues in the data. So do you understand like how to actually check normality in our data? Dr. Binh, you can just explain a little bit with your students. Yeah.
Yes, thank you so much. Thì thưa các thầy cô và các bạn, thì các thầy cô và các bạn cũng sẽ thấy rằng là cái bước này nó rất là quan trọng trong cái phần dữ liệu. Thì ở trong cái bước này, từ cái bước đầu tiên đấy là với những cái bộ dữ liệu ban đầu ấy, cái biến thực của mình thu thập về nó rất là lớn, để tránh là ví dụ như là khi các thầy cô hồi quy mà sử dụng một cái biến giả sử như là sản lượng hàng triệu tấn với cả một cái biến RA là không phải mấy, đến lúc nó sẽ ảnh hưởng đến cái hệ số beta, thì mình sẽ chuẩn hóa là bước thứ nhất. Sau khi chuẩn hóa xong thì đến cái bước này thì thường ở trong mình làm là hay mình cho vào mình sum là mình sẽ thống kê mô tả. Tuy nhiên mình không có cái bước kiểm tra chất lượng dữ liệu ạ, và đây là bước kiểm tra chất lượng dữ liệu. Thế thì mình sẽ nhìn thấy Quantile ở trong các nhóm mình check, và sau đấy thì trong cái plot này mình sẽ nhìn thấy là cái dữ liệu của mình ấy đâu đấy nó vẫn có những cái outlier rất là lớn. Và cái việc outlier này nó sẽ ảnh hưởng đến cái việc là ví dụ như là lương của nhân viên ngân hàng ấy, ngưỡng nó sẽ từ 1,5 đến khoảng 20 triệu. Hầu hết là lương như vậy. Nhưng mà mọi người sẽ đưa lương 300 triệu của ông giám đốc vào ạ. Dẫn đến là khi mình tính trung bình ra mình sẽ thấy cái giá trị min của nó rất là lớn. Và đây là lý do tại sao mình phải check rất là kỹ. Và nếu mà có những cái outlier như vậy, mình ảnh hưởng đến cái biến gọi là lương ấy, thì mình nên bỏ cái lương của ông giám đốc ra, thì nó mới đảm bảo cái việc là cái phân phối của mình sau này nó chuẩn hơn, và cái việc mình dự báo cái lương nó mới được chính xác. Okay, thank you so much, Dr. Kazi. So you can continue.
Yeah. So, dear colleagues, you can present this way about our variables, and you can put all this information in your methodology when you talk about data. Like in methodology, I usually make 3 segments. I will show some of our paper later on. Like first one, I put like data and source, where I explain about data. We can put different figures about different variables, maybe before transformation or after transformation. We can put maybe descriptive statistics and correlation also can be shown there. After then, I put a table of the variables, what variables I'm taking, and what are the source, what are the measurement. After then, I put usually in accounting, they create some framework, but in our case, in economics, we make some equations. So empirical equations, I usually put like this. Like this equations and description of the equations we put in the second part of the methodology. After then we put which method will be used to analyze this, maybe quantile regression or ordinary least square. We can put, and we can put the justifications why we are using this, what are the benefits, how can we offer best result with this method, and finally we put like and it's justification why, and maybe some people can write which package they're gonna use. So these 3 segments, sub-segments, usually we follow in writing methodology. So you can put that in your methodology. So we can also examine or say like quantile plot. It called like QQ plot. It also can be done manually without command, also possible from here. Graphic. Yeah, quantile plot. If you want to do manually, also can possible, but I usually prefer like this. So we said like there is a hypothetical curve in 45-degree. This is like normal distribution line, and we can see our data even after transformation. It deviated from here. So it shows like still for ROE, there are some extreme values which is abnormally distributed. And this, if we provide this figure, this really like it gonna upgrade our paper. If we put these things in our like methodology, or maybe in introduction, if you just put introduction, better to use without transformation, just ROE, and show this the trend of the data for quantile quantiles figure, better to put in methodology. We are showing this way data is still after transformation is not normal. So how to deal with these abnormalities? So you have to find some methods that method can deal with abnormality. So you can do for other variables also, maybe, okay, female board members. Yeah, see, like for female board members also, after transformation, data is, even if it was normal, it should be like very close to the this hypothetical line, but still it's like deviated, but close, still deviated. So abnormalities, we can experience abnormalities in the data. So now we can go for regression. For this, till this, if any of you have any question or any things to know, we can go for regression. Yeah.
Dr. Kazi. Các thầy cô và các bạn có câu hỏi gì khác không ạ? Liên quan đến những phần mà mình vừa mới thực hành xong đấy ạ. Mình transform cái dữ liệu này và mình sẽ kiểm tra check cái data quality ở bước đầu tiên ạ. Yeah, I think everyone doesn't have any questions because we just listen from you. So for now, you can go ahead.
Yeah, no problem. So if you don't ask question, it's also okay. So what we can do is, fortunately, the session is being recorded, so you can watch it and practice it by yourself. Then you will understand more deeply. And if you find any obstacles, you can discuss with Prof. Binh, and maybe you can talk with me also. I can maybe help. Dr. Nile also here. She also very good, better than me and others. She also can help. No problem. There are many actually who can help for analysis issues. So now we can like go for a simple regression. Just write reg and put your value variables. Very first variable should be your dependent variables. Maybe for this practice, you can just take ROE, then board size, board meeting, and female board members. Maybe this few variables we can see. And also, if we take many variables, the R square and adjusted R square will be very high. So the reliability, the ability of the model to explain the relationship will be less. So it's not very good to take many variables, like 5, 6, 7 is standard. If you want to consider like more than that, maybe you have 10, 12 variables. In accounting, I saw some of our students, they come with like 15 variables, 20 variables, 15 hypotheses, and they want to run in one model. So if they want to run one model with many variables, so it's not going to explain our model. So what we can do, we have to split. Like maybe first we can examining board size and few variables, like 6, 7 variables. Then you can make another model where you can drop some of your variable from here and take some of the variable, but it should be justified by some practical facts or also theory. Yeah, when we talk about theory, remember always, any relationship of the variables, theory is too much important. For this framework, I just took what Prof shared, and I'm not working in accounting things, therefore I'm not very familiar with this sort of variables. Maybe the framework is not perfect, but it's still okay. We can just like for practice, we are doing this. Okay, do not take it seriously about this model. So this is like OLS, ordinary list. If we just put regression, just reg, and put our variables, first dependent, then independent variables, then it's gonna provide OLS estimation. Very first, we need to know OLS. So OLS, it shows like both size is positively significant, very highly significant. Board meeting also significant, but negatively. I don't know why. Female board member is highly positive and significant, it shows. So if we want to go for standard quantile regression, then we can just put Q here. That's mean quantile regression, QReg. This is also provide almost similar results, a little bit different. And the coefficients also similar, because the earlier model, it considers like mean value. Here, this estimation is based on mean value, average value of ROE, and the others also, I guess. Then it examine and drop or didn't consider the extreme values. And here, this like standard quantile regression, it only considers the median. You know the median. What median is? Median is the middle value. Not actually average, not mean, but from that value, it goes upper, maybe 50 out of 150, or like this sort of value, but not average, is median. One second, can I? 1 second.
Yes, the median in divides the population into the two subsample with the same value.
In RE, there is a gathering, so they are asking me to join. I already informed them I'll join later after this. So this is like median value. Median value based on this regression is like based on the median value. This is like standard quantile regression. It only produce also one coefficient, but little bit different is based on median. So yeah, like there are some other plot can be presented. There are many plots actually. You can try. So if we go for quantile for for many cluster or many segments, we can put after QReg our variables, then comma quantiles, and we can put these values like first 25% of the data, then second 50%, from 25 to 50%, then 50 to 75. Yeah, you can put more. It's up to you. From 10 to 95, even you can put 90. Okay, we have to do it one by one, maybe. Option quantile are not allowed. No problem. We can deal with this. If it doesn't work, we can just go
So I
on.
think it's just maybe 75% because it is a third quarter.
Yeah, like by one by one can be done. Like this is normal to deal with this sort of things. Like this is from 25 to 50 quantile. How it shows like little bit change in coefficients. And earlier it was from first quantile, the female board members significance was like 0.03. Now like more highly significant. Earlier like moderate significant, now highly significant. So it meaning when a female board member is less in a company, it has return on equity, right? Return on equity will be less, but it's still positive and significant. But by the second quantile, from 25 to 50, it shows like when female board member already rise and ROE also rise from 25 to 50, like the response of female board member is now more positive. So like we can say that like 90. But here it shows like interesting result again. Too many female, it makes like little bit problem in return on equity. That's mean moderate number of female board member in a company, it really support the growth of the company. But when it goes too many, then it can distract growth a little bit.
Oh, no, I can't wait to you see. Yeah, I would like to introduce Dr. Kazi Pabang. Good morning, Dr. Professor Kazi. I'm so sorry.
Prof. Kathi,
Welcome.
Good morning, Kazi.
Good morning, Prof. How are you?
Hi, good morning.
Professor.
Yeah,
Very good morning.
we are in mid level of the workshop. Just we are start analyzing our data with standard quantile regression. So this value shows like the top quantile when the ROE is like very high and female board member is like very high, also it shows, and its response. That's mean like in when too many meeting or too many board members, female board members, it gonna distract the growth of the company. So earlier by the OLS regression, we can only provide one coefficient where it shows like all coefficients, board member, board meeting, and female board members are highly positive and significant, or highly significant. But when we split the data from lower value to higher value, like when board size is big, board member is big, and ROE also big, female board member also big, how it responds? We find that when these things are very high, then company's performance is not very expected. So we can come to a conclusion like that, like from this, like 50 quantile, 50%, like moderate presence of like female board member and moderate board meeting can support the growth of the company. But when it gets too many meeting, it really maybe distract the company's performance because they're busy with meeting without work. It can be like that. So from quantile regression, we can provide this like deeper information, not like one value. So after then we can go for simultaneous quantile regression, where you can put standard quantile, then we can go for simultaneous. Simultaneous is like to provide several quantiles in one regression, like this. The one we tried, this one. We can put like simultaneous SQReg after then our variables, and we can put our quantiles, expected quantiles in. You can change it. We know we have freedom here, and see it provides different coefficient based on our segments of our data. Like first 25% of the data, and second 25 to 50% of data, how it responding. And we can put these findings in paper, not this way. We can process it with different ways. There are some ways to do that. Like this. But we have to change our directory. And remember, like this, like if you put more, like 0.10. 0.10 means 10% of our data, 25, 50, 75, maybe 65, 20, 0.30. So you have freedom here. 0.40, 50, 60. So you can make different cluster in your data. So it's gonna take little time. After then we will try bootstrapping. Bootstrapping we usually do for to deal with abnormalities. So here it provides like with small segments of our data. So there are many segments, and we can.
This is look great. look great in that results. So from these results, I would like to raise one question for all Professor Joyce today. You can see in total population the effects of both mixing is positive. However, when we divide in the subsample, you can see that around to
Quantile.
70%, quantile 70%, the effects is negative, right? From 80% is positive effect. So when I read in the previous study, some studies raised the inconsistent effect of both mixing on the firm performance. In some case, it's positive, in some case, it's negative. It means that from the raise, the recommend that from 8 or 5 to 10 meeting per year is suitable. It reflects that the both meeting is good and the company that gets trouble. However, in some case, the company gets some trouble. They have to meet frequently. So it means that the both meeting is high.
Yeah, like in extreme quantile, like quantile 5, it shows ROE also high. At that time, board size also big, board meeting also many times, and female board members also many. So in that case, everything when very high value, it shows not that much effective company's performance. When everything is very high, like meetings, size, like maybe it is like a little bit hard to manage about the company, therefore it's not performing well. But when it is like moderate, like in 50, it shows like all the values mostly significant. Yeah, board meeting is still negative. I don't know why, but still. But in extreme quantile, it's like, oh, it's still not going okay. Yeah. Here it shows like when meeting is little bit increasing, the value from negative to going to be positive. That's mean in this like Vietnam's data, right? Your country's data. So we consider many companies. It shows like still company need maybe more meeting, more meeting to run the company well.
However, when the effect is positive, but the p-value is higher than 5%, right?
Yeah, it can be. Yeah. So we can provide this offer this result with more concise way. Therefore, we have to make another command for this, and before executing this, we have to change our directory. You can go to file of your data, then change working directory. Then we have to find our folder. I just put it in desktop. This one, MMQR, Vietnam. Yeah, we already changed. Our data will be stored, our findings will be stored there. Then we can execute this outreg 2. Then if you want to see, yeah, here is our summary of the estimation. You can just copy here, copy like this, copy, and put any Word file. just paste it here. But after paste, you have to still do something else. Like this. You have to select all, then insert into table. Then later on you can clean.
Can we run the SDoc syntax?
For
Yes,
for quantile regression, no.
yeah,
For
we can show the SDoc to show all the results in file doc. The file,
also,
yes,
also
what
can
file?
be, but for quantile regression, we have many estimation.
Yeah.
Therefore, it has like special command outreg to store the command in somewhere, still in this data. Then you have to copy it, paste, then you have to put this way. Later on you can show it more good way. Yeah, this way. When here is the quantile, so the many quantiles, you can then explain this, why lower quantile working this way and why higher quantile response this way. So most of the times it varies from lower to higher. And when you explain all this, we need to go to practical context, why it can be varied. Then during our interpretation, we have to bring out the theory how both sides can respond on ROE. We can go for theory when we explain this, and from lower quantile to upper quantile, why it's differentiate and provide different results. So now similarly, we can go for this like simultaneous quantile regression. Then it can be done for bootstrapping also. If like bootstrapping is like replication. If you can see, like our variable is x and y, and it has three distribution, 1, 2, and 3. So this three ways it can be organized. But when we run bootstrapping, so by the inside the model, it can make some different arrangement. Like it was earlier, it was here 1, 2, and 3. This order it was. But when we run bootstrapping, it can make different arrangement to show when we make different order of our values of x and y, or dependent and independent, how it responds. Like in first Z1, it shows like 3, 1, 3, like different order from this. And second one, Z2, it shows like 2, 3, 1. Like values of x and y are differently showing, then it analyzes and shows how it responds. Meaning, during bootstrap, it makes many other models from the same variables with different points. Then it provide a coefficient. So it gonna track the role of extreme values also. So to deal with abnormal data, we can also go for bootstrapping. like the same thing, just put some replication. Sometimes it take little time. Okay. So now actually it makes bootstrapping, it depends. Like we have quite long observation, we can take more replication, like 1000 also we can take, since our data is observation is quite long, many companies, but the year is less. If we had like more years and more companies, then we can put more replication here. But sometimes it take long time. If it is like many observation, it takes like half an hour or 15 minutes, 10 minutes, or I don't know for us, for today, how long it's gonna take, maybe 1-2 minutes. It actually makes many replication of our variables. Then gonna provide some estimation. Maybe estimation will be similar, maybe. So doctor, you can, the estimation is here. With bootstrap. So we can see again this estimation by by making a command outrect2 using my file. My file, we can see here. Here your result already stored here. So you can also just copy from here also. You can similar way, the way we copy. It's little bit tricky for quantile regression when we go for many quantiles. To extract the result is not like regular other methods. It's little bit tricky. So if we see, we find the results here, and we can copy, and it also stored in our folder. We already choose. If you forget, we have to choose this way. File, then change directory. Directory, you can just choose any of your working folder where the results will be stored. So here we use my file. So one my file created in our folder. Here again we also use my file. So that's mean earlier my file will be removed. So if you want to keep this result in another folder, you can write another name, my file 1, then my file 2, like that way. And if you want to put this finding, so I forgot to show that for earlier one, I can show it again here. We can show this result in plot also, not only by the table, but also by figure. It's generating. So this is like coefficients here, and here the quantiles, like 20 quantiles, 40, 60, 80, 100, like 90 here. So you can show like response of both size on ROE, like when it is like 10%,
Nice.
it has like more stronger.
Mm.
And when it's like both sides is small, very high, and the ROE is like very high at that time, at the like high efficient time, very big boot size, is not really helping companies' growth.
Mm.
It shows by the extreme quantile. The value is coming down little by little. But board meeting is different. Board meeting is really when in, but you know, where it can be varied from different group of companies, different countries. So like we can always mention that in our context, in this group of companies, in this country, board meeting, like frequency of board meeting is when very high, it really support growth. That's mean still they are still yet to reach the threshold of board meeting overall in Vietnam maybe. So this way, like if it was wireless, it could provide only the medium coefficient. But here we show from different segments when it's low, when it's high. So this is the beauty of quantile regression.
Kazi, Musa, can I ask a question?
Yeah, sure.
Can you please show back to the plot graph again?
Yeah,
To the
yeah,
graph?
yeah,
Yeah.
sure.
First of all,
It's generating. Yeah.
First of all, I'd like to thank for this seminar. It was very good. I wish that I attended from the beginning, but because I have the class, then I came just in between. But it's enough time for me to catch up this one, Musa. It's very nice, and for me, I haven't done this simultaneous quartile regression. Usually, I just use the normal panel regression. But this one, the graph is helpful, very helpful because we see the movement, right, Musa?
Yeah,
Right?
yeah, yeah,
We see the movement.
yeah.
That if there are different quartiles, how the variable will react to
Yeah.
the changes of the quartiles. In this one, when the graph plot this way, is this one related to the quartiles we put in Stata? Because in the Stata, you have different sets of quartile, right? Like
Yeah.
10, 20, etc. But when the graph plot, this one is 20, 40, 60, 80, 100. I think it must be in this fashion, right?
Yeah, yeah. Based on that findings,
Mm-mm.
these findings actually showing by
Because this one, you see, you have 90, 70, right? But
yeah,
from that, the Stata software take the information and plot this graph for us,
yes.
right? In the different quartile. Because we have not put these quartiles, right?
Oh no, we
The
put
different
this.
levels of quartiles.
We put this here.
Yep. We put
Yeah,
10, with 10, 20, 30, 40,
90.
increasing by 10.
You can
I
see it start from 0 to this. That's mean here is 10.
see.
Uh, then this 40, this is 60, 70. Like if it gonna provide all 10 and many more, it will be more messy. Therefore, it provides like 20, 40, but in between you can say this is 10.
I see.
This is like 30, this is like 50, like this.
Musa, if we don't put the quartiles in such details, like in the command
Mhm.
windows, if you put, for example, if we put only 25,
Yeah.
50, 75, and
Yes.
will this plot shows the same?
Uh, According to your command, I can show you again. Like this really,
Okay, if we change the command.
yes, yes.
So
Yeah.
we can determine the threshold of quantile, for example, 25, 15, 75 or percent, or you can divide into 10.
More details, right?
Yeah.
Yeah, yeah. We can do that. We can do that now. Like 25
50
point 50.75 or something. Anything you can write in between 0 to 100.
Uh-huh.
Be like little bit logically we can put.
Mm-hmm.
Then we can again produce plot.
Mm-hmm. Hello, Tui.
Yeah, good morning.
Good morning. I see, Musa. Now, because the command is rough, right? Because
Yeah,
we
yeah,
put just only 25, 50, 25,
yeah,
then the plots here also rough, not
yeah.
so details.
Not so
Then it's based on what we put the commands
yeah,
in the at the first place. I see now. I got it.
yeah. So we have freedom here.
Wonderful. Very good,
Yeah.
Musa. Excellent.
Yeah.
Mm.
Yeah. So it was like bootstrapping, and we can just produce for I forget to produce simultaneous quantiles figure. We can just produce with it was
Quantile. Okay.
yeah it was already. So now we can do.
This
So
one simultaneous quantile,
it
right?
was simultaneous with bootstrap, without bootstrap. If we find our data has like is really long data and has abnormalities, it's better to analyze with bootstrap. If like we have a little bit small data, then maybe we can avoid bootstrapping. It depends.
Mm.
And to produce the result, also you have to give this command, because
Mm.
other methods we can just copy.
Mm-hmm.
Here like results are quite long, therefore better
Mm.
to produce result by that command.
Mm-hmm. Mm-hmm. Mm-hmm.
uh, so Prof Binh, uh, do your like students wanna practice a little bit, or I should continue quantile moment?
So you can continue,
I
please.
can continue.
Yes, I will send the record for all the audience to practice later.
Okay. This is in between before what it called a quantile moment. I want to show a little bit like this one. Someone want to enter. It called fixed effect quantile.
Mm.
XT. If we put XTQreg, earlier it was not fixed effect, but now it will be like if we put XTQreg and execute the same command,
Mm.
it shows something warning of the fitting value of this scale function are not positive. Whatever, there are some issues in
But is
fitting.
this one fixed effect? Is
This
this one fixed effect?
is with fixed effect. Uh,
I don't see you put FE. Is
uh,
that no need to put FE?
Here no need to put in quantile regression, no need to put. Just we put XTQreg, and then it gonna produce fixed effect quantile regression.
What's about the random effects?
Usually
Musa.
these are the random effect without like simultaneous or regular
It's random
regression
effects.
is random. And specifically if we want to do, like there are many variants of quantile regression. Some of the variants we are discussing today, still there are something else like quantile on quantile and quantile ARDL, quantile, some other methods also have. I'm just showing the variants. If someone want to run, I find little difference. I need to actually know more about like what are the actual difference between all these things. Okay, let us produce some figure, maybe we can compare. It's producing from less quantiles. We put yes, see the figure also little bit different from earlier on. Earlier on, I also can produce. Here the only
The earlier one is the random effects, right? If we don't put XTIG,
yeah.
then it looks like to me now when we see that one, we see kind of the changes and it's more meaningful.
Yeah. So this way we can actually compare the effect. And finally I want to show in here fixed effect there is no intercept actually it provides. Is the only difference. And finally we can show quantile bar moment. Quantile bar moment is the most updated version of quantile regression. It offers scale and location effect. Scale location is company to company or country to country difference or state to state difference. And scale is effect of time in different time, how it can be the response can be different or be similar or different. It can also provide this information by quantile bar moment because it provides moment. And it also, and this variant is really robust because it can actually address most of the abnormalities issues. Any issues like endogeneity or any like heteroscedasticity, multicollinearity, or any endogeneity problem in panel data, it can deal. Like other quantile method can be applied for maybe for time series data, but quantile bar moment applicable only for panel data. These are the things. Then we can go for it. We can go for maybe for many quantiles without replication. We have to go without replication. We can just put like MMQ reg, and then the similar thing. Then you can execute. It also provide, we can better watch it by figure. Figure it's more easy to see the difference. Yeah, similar thing, but different way we are presenting. And if we use this quantile bar moment, we can justify like more strongly. Earlier, before Prof. Kazi joined here, we show like our data has many abnormalities, which we couldn't track by several ways. Then we went for some specific normality test by figure and by Jacobi test also for individual variables and by figure also. Then we find data has abnormalities. And if data has abnormalities, if we use quantile via moment method, then we can convince our reviewer like why we use this method for abnormal data. We can say that this method whatever it does inside, maybe we don't know, but we know that it can deal with that, deal with any of these problematic issues in the data. For these issues, usually any type of wellness-based method really hard, and reviewers can ask you can provide this this test. You need to provide this test, and if you have these issues, multicollinearity issues, then you have to maybe change the method. But in Quantile, whatever you provide this test or not, if you provide, also good. If you don't provide, you can say that this method is already can address this issue. So whatever this problem is there or not, it doesn't matter actually, because it can deal. And we can very first just shows the data behavior. It is normal or abnormal. Even normal data also, I said we can use that. Because normal data, if we want to provide information about different segments of our variables response, like for 10% or 40%, how it responds, then we can also, for normal data also, we can use any of the Quantile regression. But better to use the most updated one, Quantile environment, because it developed in 2019 and addressing all the problems were faced by previous variants of Quantile methods. So this one is most robust still in Quantile regression analysis. So I just today I was showing. I spent long time every day in my research kit. So today I find one paper is published in Sustainable Development. This is one of the top journal in development economics, and they used quantile moment. I was so surprised, like, yeah, here. So if we want to target good journals, like journal of like this sustainable development, Prof, this journal from Thailand. This sustainable development, this journal from Thailand.
From Thailand.
Yes, yes.
I ha ha.
This is
Sustainable development.
very good journal. Very good.
Yeah.
Q1, right?
Yeah, very Q1, very consistent Q1, not only Q1. So I find like today, this paper is published in January by this person.
So please share the link via the chat box.
The link.
Yes.
And I also can share some of my publications.
Yeah.
We used Quantile moment actually we used.
So for traditional methods, we often check detect the defects of the model before the final stage. For example,
No, you can directly use that.
Yes, with MMQR,
Yeah,
you don't need to check, right?
you don't need to use all the quantile regression, but you can use directly this one. But earlier you have to show that justifications, like the response of your dependent variable, independent variable on dependent, can be different in different segments. This is one justification. And if data is abnormal, then you are like more justified. I have abnormalities, this non-parametric test. So I better use this. if we use normal regression, regular parametric regression like OLS or even ERDL or any other, it can be like spurious result. But in those methods also, they have some things, some tools to deal with abnormal data. So most of the data, they harmonize the data, make it like normal, then regress. But in quantile regression, it keep the data abnormal. So this is the strength of this method. Like how extreme values or very low values, how it responding or responds. So it provides like very deeper information. Yeah. So
Musa, can I ask, still interest in what you just said, that if the other regression, like even we use the fixed effect random effects, normally we try to normalize the data, the samples, right, the respondents, because sometimes it's the extreme minimum or maximum and make the very high standard deviation.
yes.
That's why we try to visualize, right? Visualize the data. But in the quartile regression, we keep the data as it is.
Yeah.
Is it?
Yeah. Yes.
Then we don't care for the extreme data.
Because for extreme, like for quantile, top quantile, only extreme values. So how extreme values can respond. Also, we are providing how like mid-level values are responding. How very like also like very primary like lower values responding. So this way we can provide information. I just charge my PC. Yeah,
the extreme data are very small numbers, like only a few data, the respondents or samples are extreme. In this case, it is okay, right? Still okay to keep, because in normal situation, we try to visualize it, or we try to drop out the extreme data, right? One that is outliers, we removed it. In this case, we keep them, right?
Yeah. So therefore, like frequently I use this method because it gonna fit with most of the types of data. If it is normal, I also can justify why I used it to provide response of different segments. If it is like abnormal, then it is more justified. I didn't change the data. I didn't torture the data. Keep it as it is. Then to see how it responds with normal values, extreme values.
So we can have to explain the difference in the assessment, right? Because for example, we can see the quantile, for example, quantile S or 9 for outlier of the data set, right?
Yes, I want to show you like
the results when we analyze this. So we have to decide in the difference between the quantile to show the effect with the subsample, such as the sample with outlier.
Yeah, like we have to say that this is
Go ahead. Just wonder how to find the extreme data and the benchmarking of the extreme data, because in a normal way, so sometimes we can consider, oh, the data is normal. So how we can decide the extreme data?
Dr. Thúy mentioned about the how to divide the quartile the
benchmarking for the
focus on
extreme
the
data.
outlier. You know, in this case, we use quantizer, so you can see the outlier in some quantiles subsample. For example, more than 75%, for example, 80% or 90%. The outlier often so is in the subsample of quantile.
So is it you are asking something or make a statement?
So Dr. Chief mentioned about for traditional method, we often check the data and then we have to eliminate outlier before the analyzing.
Analysis, yeah.
Yes, for quantize, so we cannot.
We
no need
don't
to
need, actually, we don't
no
need.
need
to
to
do that.
eliminate.
Yeah.
We
No
will
need.
check the quantize and
Yeah.
compare the difference between traditional effect that we can see all the data sets and then we can compare the difference with the normal and outlier data, right?
Yeah. Like different segments, how lower value responding this, how upper or extreme values, how are they responding. So no need to drop or eliminate the outliers, but we can provide outlier as a strength of our model.
And there is a need to show the data characteristic in the symbol in the methodology section, right?
Yeah, I will. Let me show you the
I
thing.
understand. Thank you.
Prof. Katie was not here. I can. However, I will share this this paper. We published this paper in few years ago. I also used quantile regression for this. Quantile by moment. Quantile by moment regression we used, and we published in SSCI journal.
Could you please pause just a second, Musa? There's a table that shows the descriptive analysis.
Yeah.
If we don't remove or eliminate the outliers, because it is like the strength of the using the quartile moment, then in the descriptive statistics, it will show very high standard deviation.
Yeah, like here. I want to show
The
you.
previous one, I think. Let's see. Which one?
Oh, where it is?
No, this one, literature review,
The
the descriptive.
Yeah, I'm also looking for. Yeah, descriptive stat. Yeah, here.
Oh, yeah. Previous one. Yep, this one.
Yes, like we also provide, like here, corpus is very high. Then this one also high.
High. But the standard deviation is still acceptable in this table.
Is
You know,
stable.
it's sometimes when we have very extreme data, this is the case that happened to me because the skewness catesis or maybe like this, but also standard deviation is too high.
Yes.
Sometimes,
So we have to show the method we use in the methodology. So Dr. Kazi, please send me or audience some previous study use methods that show the MMQR can address some problem. So we can, when we write the methodology, we can cite the previous study. This means that this method can show some problem with the abnormal data.
Data.
Yeah.
Yes, not we have to explain with the reviewer about the method, right?
I want to show Prof. Katie again. A little bit, like in 5 minutes. Yeah, here we can just go for normal descriptive stat. Then we can descriptive statistics with the normality test also. We didn't find much here.
Skewness or catesis.
Yeah, a little bit. Then we went to little bit deeper for individual variable. Like here we find like for board of director, the Jacobi test shows like abnormal things. Then we can go little bit deeper by producing figures like quantile figure, like distribution. This is this curve. This curve is like hypothetical normal distribution curve, and we see like even after transform the data, log ROE is like deviated from the normality. So this figure we can provide in methodology section in our data details. We can put that and we can show like by the descriptive stat when we run together, it is still maybe cannot provide the deep distribution of the every variable. But when we produce the figure like this, it actually shows the ROE is abnormally distributed this way. Yeah, and some other box. Okay. This one is normally distributed. So let's see the ROE. So this is another box plot. We can also provide in methodology. Like this is the normal distribution point, but you can see some extreme values here. Very minimum extreme value and very higher extreme values. Even after doing all after transforming the data. So before transforming, it will be like more extreme. So this way we can justify even after showing the descriptive stat. By Jacobi test, we also include then some figure. Like this one is like quantile plot, then box plot. This way also we can show the normality of the data, the distribution. Then we can go for it. So I guess, oh, another thing I just didn't say is, oh, so very first, it shows location and scale effect. Location and scale effect also we can provide information how when company varies, company to company varies, how it responds, and when time varies by scale, also we can provide information. Usually most of the people don't report this, but still we can, if we want to report also some extra value, but we also can show like how location or country or company to company, how those factors actually responding with the dependent variable. Also, this is like some extra things of quantile by moment method. So anything. So should we continue with DOLS, FMOLS? I can just show it. I can just show it in 1 minute. But it also needs some justifications. But if we use as the robustness test, we can just go for it. I don't know whether it's gonna work or not. Yeah, it's working. Like this, it also lagged based on lag model, lag, lead, and VLAG. VLAG maybe, I don't know what is it, but several lags, it considers several lags and lead, then provide the coefficients. So in many papers, I used it as the robustness check. Maybe in this paper also I used. Like after, yeah, in this paper I used like, actually not we used Wallace fixed effect and random effect. This like basic model, but after using some advance, we can provide as robustness with some different methods like OLS or a dynamic OLS or anything. So these are the what it called the syntax, and this is for dynamic OLS, and this for fully modified OLS. But if we run this dynamic and fully modified OLS in the main analysis, we have to provide some justifications. Maybe it can address multicollinearity. If there is multicollinearity in OLS, then it's better to use fully modified or dynamic OLS. Then there are some Houseman test also to choose which one is more reliable. The same way we can do. So this way we can present our paper if we provide information with some advanced method and with some this sort of methods. We can even argue, we can convince the reviewers about our findings. It will be like little bit, life will be a little bit easier to publish in good journals. But always we have to remember like data behavior should decide the method based on the theory and everything. Yeah, so any question or any comments? I actually am learning. I'm not that experienced.
Yes, that's a
Maybe
great.
I ask a question if it is still okay the time
Yeah,
can
bro.
be.
Yes, yes,
Okay.
it's okay.
Maybe
One
yeah,
question.
just one question, just one question. Because I have not come to the point when you run the scale and location. I like to ask the variable when we say about location, because this one can see how the data behave in the different locations, right? Between the companies.
Yes.
When you collect the variable value for location, is it the dummy variables, or how do you collect the
Uh,
data for dummy, or how do you do
oh,
this on the location?
it's like everything normal.
Uh-huh.
This is the extra things what quantile via moment can give us.
Mm.
With the same analysis, like
Mm-hmm.
other quantile regression, quantile via moment, it also provides some information about how location, like different combination, different countries or different time, how it can respond. Like by the method, it can automatically provide.
Then
But
in this case, the when we collect the data, we have to identify like this company is located in which area or which countries. Is that we also need to do that, right? When we collect the data.
no, not necessarily. But
Otherwise, how is it then? The location.
yeah, location means different. I can show you again. Okay, one thing.
Mm.
Just 1 second. Okay.
In this sample, we use the location
Company,
is a
right?
different company in your data set from your paper. Is the
And
location in the country, right?
yeah, location is the like company or countries or individuals. Like how company to company varies. Like for this variables response, it shows like uh, this is like significant, meaning like in lower quantiles, but it's common for all location. Okay, it provides only one location. Whatever, for all companies, location is like significant. When one company to another company, the response of these variables are significant. It also providing this information, or by the scale in different times about board member.
So it means the dimension in the panel data, one dimension is the company. It means the location and one dimension is scale. You will focus on the time, right?
Yeah, one is time. Time is
Scale
scale.
is time. The location is location.
Location means company or individuals.
Companies,
Country. So
countries.
company to company, the response of this of the both sides is significant. That means one company.
So it means that one with panel data, you can see, for example, one company have the 8 or 10 observation, right?
Yeah.
So it's the same characteristic. So you focus on the difference in the company, one company with other company.
Yeah, this is like overall response, like from one company to another company. Are all the companies responding similarly? Or they're responding differently? It is actually showing. And also time, like are all time the response is similar, or in different times response of these variables on ROE is similar or not.
The negative is the different, right? The different time,
Yeah.
the responses, the sample response in the different ways, right?
Yes.
Yeah.
Yes.
Very good. Very good.
So this
Nice
information,
interpretation.
this is not mandatory to report, but it's like something extra. I find most of the studies they don't report it, so I also don't report.
For example, in this case, we no need to use location and scale. However, in some case, we can apply to test the location and scale, right? So HR.
Yeah, it's up to you. You can report it if you wish. No problem.
Yes.
Yeah.
Thank you so much, Dr. Kazi Musa. And everyone, if you have the question, please raise the question. I think it's enough for today. Yeah.
Really thankful to Prof. Kathi when she came. Then the session it converted to like more interactive.
Yeah.
Yeah.
I would like to say thank you for Dr. Kazi Musa for your presentation and guide for all audience today. Thank you, Dr. Naila Arum, Professor Kathi, and all of us to join us today. Dr. Thủy, are you here? Yes, maybe see in another meeting. Yes, thank you so much for joining us today, and I hope that we can have opportunity to collaborating in the future. Thank you so much for joining us. Bye bye, and see you in the future.
Thank you very much. Thank
So
you.
now
Thank you.
to take
Thank
a
you very much. Excellent. Love it. Yeah.
thank you so much, Professor Kazi.
Okay.
Thank
All
you.
right. Bye-bye.
Bye.
Bye bye. Thank you so much.
Yeah.
Thank you so much.
Thank you.